Unit 10, Day 4, Parallel and Perpendicular Lines. Okay, so determine whether the following lines are parallel, perpendicular, or neither by graphing. So first thing we want to notice is right here. First line, the slope is, so it's y equals mx plus b. The slope is always in front of the x. So our slope is negative 3 for that first equation. Second equation, slope is also negative 3. All right, so let's graph these. So first and only difference, since they have the same slope, I'm going to start at 0, 4. Now it's a negative slope, so it's going to go down 3 to the right 1, down 3 to the right 1, 3 to the right 1, etc. Okay, so let's see. As long as my points are perfect, it doesn't really bother me too much if my line's a little crooked. Because there's my first line. My second one, I'm going to start at negative 5, so 0, negative 5. Negative 3, so down 3 over 1, down 3 over 1, up 3, to the left 1. Okay, so take straight edge, or I'll just sketch a line there. What do you think? Those two look like they are parallel. They look like they're perpendicular. So we often think of parallel, perpendicular, that kind of crosses 90-degree angle, or neither. They're just neither one of those two. Looks a lot like these are parallel. Okay, parallel. Okay, number 2. Slope of the first line is 2. First line is 2, and the slope of the second one is negative 2. Okay, so if I'm going to start with this first line, 2x plus 3. I'm going to start at 3, 0, 3. In fact, why don't I use a different color for that? Start at 3. I'm going to go up 2 over 1, 2 over 1, 2 over 1. So I'll have a line that looks something like that first one. And that second one, I'm going to start at negative 4. So I'll start at 0, negative 4, and it's a negative 2, so I'm going to go down 2 to the right, down 2 to the right one, down 2 to the right one, and it'll look something like this. And so the million-dollar question for today, does those look like they're parallel? No? How about perpendicular? Perpendicular would be kind of this 90-degree angle. Does that look like a 90-degree angle there? If you kind of tilt your head or turn your paper, 90 degrees to you? I don't think so. Okay, so this one is going to be neither. Neither, or neither. Before this day's up, we will have a firm and fast way to tell which one's which. All right, so number 3, negative 3x plus 7. So the slope is negative 3. 1/3 x plus 7. Slope is 1/3. Okay, so if I go to graph the first one, you can see negative 3x plus 7. So I'll start at plus 7. Negative 3, so I'm going to go down 1, 2, 3 over 1 to the right, down 3 to the right 1, or up 3 to the right 1. Okay, and looks like we have some points in the line there. Okay. How about that second line? Okay, I have 1/3 x plus 7, so I'm going to start at plus 7. They actually have the same y-intercept, but 1/3, so that's going to be up 1 and to the right 3. So up 1 to the right 3, 1 to the right 3, 1 to the right 3, or down 1 to the right 3, down 1 to the right 3, 3. Okay. So parallel, definitely not. They're not going side by side. Perpendicular. Well, let's turn our paper just a little bit and see. Look, 90-degree angle to you? It's pretty close to me. It may not be exact, but I'm pretty convinced that one is. So these two are perpendicular. Perpendicular. Okay. Now we've got number 4. Y equals -2 and x equals 4. Now I want to go back and just mention Hoivuk's horizontal line, 0 slope, y equals. So if you have y equals a number, it's a horizontal line. So y equals -2, it's a horizontal line going through -2. So there's -2, horizontal line with a 0 slope. So the slope of that one is 0. Okay. A vertical line has an undefined slope, and it's an x equals a number. Well, we have an equation right here. This x equals a number, x equals 4, so it's a vertical line with an undefined slope. Undefined. So it's a vertical line going through x equals 4. So that. So again, $1,000,000 question. Are these parallel? I don't think so. But perpendicular. Look at a nice 90-degree angle to you. It does. Okay, so I think this is going to be perpendicular. I know this one's going to be perpendicular, actually. All right. So this leads us to an actual definition of parallel and perpendicular. Okay, so here it is, actually clipped out of a textbook. 2 different non-vertical lines are parallel if and only if they have the same slope. So the examples we have here are actually 1/2 x plus 5 and 1/2 x plus 1. Okay, they have the same slope, so they're parallel. And then all different vertical lines are parallel. So all vertical lines they all have the same slope, right? They're undefined. So they all have the same slope, therefore they're all parallel. So parallel, it comes down to same slope. That's really what parallel comes down to. That's what you need to remember, how you should remember it. Okay, perpendicular lines. 2 non-vertical lines are perpendicular if and only if the product of their slopes is -1. Okay, so say -2/3 and +3/2. Okay, so if you multiply them and they're a negative slope, or vertical and horizontal lines are always perpendicular, they have a nice 90-degree angle there. So for perpendicular, you can think of it as, yeah, the slope 1 times the second slope times slope 2 is -1. But I really choose to think about it this way. So if I rearrange that, we have 2 things that go on. It's this right here. And the way that you'll most likely remember this is that these are opposite meaning one's positive, one's negative, reciprocals. Reciprocals meaning that it's a fraction that's been flipped. Okay, so if you can kind of see, I rearranged this definition right here to say this, that one of them is the other one flipped with a negative sign. Okay, so, but they are opposite reciprocals. That's the way I want you to remember that. Opposite reciprocals. Okay, so our task is next several of these. Really straightforward. First, find the slope. What's the slope of number 5? It's 5, just staring at you. Y equals mx plus b. If it's in that form, we already know. So the slope is 5. So the parallel slope is the same slope. So it's just 5. Perpendicular is a little different. We need the opposite reciprocal. So it's going to be negative since this one's positive. So it's going to be negative. And it's going to be a fraction, so 1/5, because you can kind of think of this one as positive 5/1. Change it from positive to negative, and flip it. Okay. Number 6. The slope for number 6 is -2. So the parallel slope is also negative 2. And the perpendicular will be, again, it's a negative 2, and I'm going to think of that as a negative 2 over 1. So I'm going to flip that, so 1 over 2, from negative to positive. So there it is. That's our perpendicular slope. Okay. Number 7, the slope is 1/2. So the parallel slope is also 1/2. So the perpendicular, take that fraction, flip it over, 2 over 1. Change it from positive to negative. So negative 2 over 1 or just negative 2. Number 8, the slope, again, just staring at us, y equals mx plus b, so 4/5. The same slope is the parallel, so 4/5. And then for the perpendicular, got to remember two things with that. Opposite, reciprocal. Opposite, reciprocal. So we have to flip it and change the sign. So it goes from positive to negative, and we flip it. So 5 over 4. Really nothing to it. All right, number 9. Y equals mx plus b. That's not in the right form. Oh gosh, what am I going to do? I must quit. That's the only solution here. No, we can get this to be y equals mx plus b. So how could we get it to look like that? How can we get y by itself? Well, easy enough. We box in our y. Well, what's over there in the keeping us from having that box by itself? It's the 2, right? So we're going to divide by 2. And we just make sure we divide everything by 2. Okay, it's the distributive property, really. Okay, we have to divide everything by 2. Kind of like when we distribute, we have to multiply everything by some number. So we get y equals 2x plus 6. 4 divided by 2, 12 divided by 2. So the slope is 2. The parallel slope is the same, so it's 2. And so the opposite reciprocal, that's positive 2 over 1. So we're going to go from positive to negative, negative, and then we're going to take our fraction and we're going to flip it. So we get 1 over 2, negative 1 over 2. Right, number 10, last of this kind, I believe. Here we want y by itself again. Okay, well, it's not really even close to having by itself, but we don't want to quit. Y equals mx plus b. So we want y by itself. So I'm going to box in that 4y right there. Okay, so what's over here? What's outside this box that's keeping us from having it by itself? Well, this 3x, honestly. So we can do the opposite by adding 3x. Why do you think we spent all this time solving for y the other day? So let's see, we get 4y equals, because that's a zero pair. And these two are like oil and water. I kind of say that over and over again, but these two are like oil and water. The variables and the not variables, they're two different things. So you can try to put them together, but just like oil and water, they're just going to spread themselves out. They're going to separate real quick. So we could either write 2 plus 3x or 3x plus 2. Just make sure that the 3 is still positive, the 2 is still positive. That's what matters. Okay, is y by itself yet? We are closer. This is more like that last one. We need to divide by 4. So you need to divide everything by 4. So let's see. 4 divided by 4 is 1, so that gives just y equals 3 over 4. Does that reduce? I don't think so. 2 divided by 4, that does reduce. 2 goes into both of them. So we get 1/2. So the slope is 3/4. Notice we couldn't get the slope until we had it in y equals mx plus b. That is our slope. We have to get into this form first before we can do any of this stuff. 3/4. So the parallel slope then is 3/4. And so the perpendicular is going to go from, since it's positive to negative. Negative. Take our fraction, flip it. Negative 4/3. Oh, nope, we have a few more. Okay. Number 11, 5y plus 3x equals 15. Okay, well, y is not by itself, and so again I get to box in that 5y. I'm going to have to subtract, do the opposite, subtract 3x from both sides. So I'm going to get 5y, 0 pair. So I'm going to have either 15 minus 3x, I can read it like that, since these are oil and water, they try to put them together, but they come apart. Or I can write negative 3x plus 15. Okay, is y by itself yet? Not quite. So we'll divide by 5 everywhere. So we get y equals negative 3/5 x plus 3. Because 5 doesn't go in evenly here, but it does go in there. So we have a negative, okay, good, and a positive. So our slope then is negative 3/5. So that means that the parallel slope is also negative 3/5. So then the perpendicular goes from negative to positive. The change there, positive, and flip the fraction. So 5/3. And I really don't have to write that plus right there, but I can. It's just not something we traditionally do or conventionally do. All right, last two. Hooivux is our friend here. This is an x equals line. So it's horizontal, so it's a vertical line with an undefined slope. So slope is undefined. So that means its parallel line would also be undefined. Now, we can't exactly do the positive, negative, positive thing with this. But the other special case is where this goes. So the other special case from undefined is 0 slope. Okay. Now 13, this one is of the Hooy variety. So it's a 0 slope, y equals line. 0 slope, so parallel is 0. So perpendicular is undefined. Undefined. We should watch Sloped It again sometime, huh? Okay. So from here, determine whether the following lines are parallel, perpendicular, or neither. Okay, so the slope for the first line, I'm going to go and write it right here. Slope for the first line is 1x, so 1. Slope for the second line is also 1. So remember, if they're the same slope, they're parallel. If they are opposite reciprocals, they are perpendicular. And if neither one of those are true, then it's neither. So these are the same slope, right? So parallel. Okay, 15. Slope for the first one, 2. Slope for the second one, 1/2. Make sure we get those. It's positive 2, positive 1. Okay. Are they the same slope? As much as you might try to make them, these two are not the same. So it's not parallel. Now, perpendicular, they need to be opposite reciprocals. So, like, let's say if I just took this one, it goes from positive to negative. I flip the fraction, negative 2. So, are those going to be opposite reciprocals? No, they're not perpendicular, so that one is neither. Okay. Okay, 16. Y is not by itself, so I pull up my pens again. So I need to subtract x from both sides. So I get, let's see, this one is going to be y equals negative 1x plus 6. So the slope of the first one is negative 1. Slope of the second one, see, I got to get y by itself there too. So I have to do the opposite. I'm going to have to add 4x here. So that's a 0 pair. That gets me 4y equals 4x plus 12. Is y by itself yet? Nope. Going to have to divide by the 4 that's in front of our box. So y equals 1x plus 3, I believe, is what we're going to have there. So the slope of that one is 1. So these two are obviously not parallel because they're not; those two aren't the same. Negative 1, positive 1, not parallel. Now perpendicular is another story because I could write this one as 1 over 1, right? So if I go from positive to negative, be a negative. So I'm trying to make that perpendicular. And if I flip that fraction, I get a 1. That actually is going to be perpendicular. Okay, so on to 17. Let's pick up where we left off before I was rudely interrupted. Okay, so when you first look at these, number 17, these two equations, you might look at them and go, gee, this looks like a lot of work. Get over that thought real quick because this isn't a lot of work at all, actually. This one is really easy. These are actually both in point-slope form, which tells us two things. It tells us that the slope of this first one is 1/4, and that it goes through 3, 3. It's the point x1, y1 that it goes through. This second equation tells us that it has a slope of 1/4, and it goes through -1, -13. That's the point that it goes through. Okay, so all we really care about right now for parallel, perpendicular, neither is the slope. So what's the slope of the first one? We just said that it's this thing right here, right? It's the 1/4. So the slope 1 is 1/4. The second one, same thing. It's got 1/4. Okay, so our options are they the same slope? Are they opposite reciprocals? Or are they neither of those? Well, these are the exact same numbers. These are parallel. And that's all we need to know. So all we have to do is, if we recognize that right there, that's it. Now you could work these out and get them in slope-intercept form. And it would just take you a little bit longer, but you could do it, and it would work. But if you see what the slope is already, then no big deal. We can cut to the chase. All right, let's get this done. Okay, so number 18. We have two lines. We want to know the slopes of them. These are not in point slope form. They're in standard form. Okay, so standard form is a little bit different. Okay, so we could graph them from standard form. We talked about the x and y intercepts. We could do that, but that doesn't tell us the slopes. So what we're going to have to do is actually get each one of these, make sure we can get y by itself. So I'm going to copy each of those equations down over here. So 6x minus 4y equals 4. Did I copy them right? 3x minus 2y equals 2? Yeah, okay, let's work. All right, so for just this first one, I want to get y by itself. So I'm going to box in that. And I want to subtract 3x. Subtract 3x from both sides. So that leaves me with 0 pair, negative 2y equals negative 3x plus 2. Okay, y is still not by itself. So I'm going to divide by negative 2. Divide everything by negative 2, actually. And so I get y equals, so that's going to be a 3, negative divided by negative is positive. So positive 3 over 2 x. And then positive divided by negative is negative, so negative 1, minus 1. So the slope of this one is 3 over 2. So I'm going to just go and write that up there, 3 over 2. Now the second equation, let's do the same thing. So we want to box in the y term, including the minus sign there. So we're going to have to subtract 6x. So we get negative 4y equals negative 6x plus 4. So y still isn't by itself. Divide by negative 4. Okay, now I see this is going to reduce here. So 6 divided by 4, so it's going to be positive, but 2 goes into both of those. So we get 3 over 2. 4 goes into both of these, so we actually get a minus 1. The slope is 3 over 2. Now, I have a little bit of a conflict here. My brain is telling me these are parallel because they have the same slope. But my brain's also telling me that these two are the exact same line. How can the same line be parallel to itself? Well, really, it can't be. So if I were to graph this, I put minus 1, grab the red pen, minus 1, it's 3 over 2, so up 3 over 2, 3 over 2, 3 over 2, and I get this line right here. Well, then if I go and I do the same thing with that other line, I start at minus 1, up 3 over 2, up 3 over 2, up 3 over 2, and we have something strange. We have two lines that are the exact same. Can they be parallel? Can they be parallel? That's the question. I'm going to say no. I'm going to call this neither. And I want to flip back to our definition and see if we can appeal that at all. Two different non-vertical lines are parallel if and only if they have the same slope. They have to be two different lines, otherwise they can't be parallel. So we kind of get in this limbo sort of place. It doesn't really fit anywhere. That may happen. That's going to happen obviously at least once. Hopefully it doesn't happen in this last one too, because that'd be a shame. All right, so let's do this one the same way. We're going to take, except for the hopefully neither part of it, we'll take 6x minus 12y equals 24. And I'm going to take the other one, 4x minus 2y equals 8. All right, so I want to get y by itself. So for this one over here, I'm going to box in the minus 12y. Now I have the 6x here, that's a plus 6x. I need to do the opposite. Subtract 6x. And honestly, I hope we start feeling really comfortable getting y by itself because we're doing this every day for a while. So negative 12y equals negative 6x plus 24. Okay, is y by itself yet? Not exactly. So let's divide by negative 12. Okay, let's be careful with our negative signs here because it's always something that's tricky. So y equals negative over negative is positive. 6 goes into both of these, so we get 1 over 2, so 1/2 x. Okay, and then we get negative by positive divided by negative is negative. 24 divided by 12 is 2. So 1/2 x minus 2. So the slope for that first one is 1/2. Okay, and that's the key to telling whether these are going to be parallel, perpendicular, or neither. So let's check this one out. We want to get y by itself, so we'll box in 2y. So I need to subtract, it's positive x, 4x, we'll subtract 4x. 0 pair right there. So we get negative 2y equals negative 4x plus 8. Is y by itself? Ought to know the answer to that one by now. Nope, got to divide by negative 2. So we get y equals, let's see, that's going to be positive 2x negative 4. So the slope of this one is 2. Now to know if they're parallel, if they're the same slope, right? Parallels when they have the same slopes. Are these two parallel? Their slopes are not the same, so it's not parallel. Okay, so if I had a list right here, I'd say not parallel, perpendicular, and neither. All right, so perpendicular if they're opposite reciprocals of each other. Okay, now you might look at this and go, oh, well, they're reciprocals, right? They are reciprocal of each other. You take 1/2, you flip it upside down, and get 2 over 1, which is 2. So they're reciprocal of each other, but are they opposites? Are they opposites? One of them's positive, the other one's positive. They're not opposites, so it shouldn't be perpendicular. This one actually ends up being neither. I hate that we end up with a couple of weird ones at the end. All right, well, let's graph these just to make sure by graphing. So this one, we already have this. Start at negative 2. So start at 0, negative 2, and it's 1/2, so up 1 over 2. 2, up 1 over 2. 2, down 1 over 2, etc. As you know, I like to put lots of points on there. Okay, so there's my first one. I'm going to try to color code that just a little bit. All right, and our second one, 2x minus 4. I'm going to start at minus 4. It's a positive 2, so I'm going to go up 2 over 1, up 2 over 1, 2 over 1, 2 over 1. Okay, so the question is, parallel? Absolutely not. Perpendicular, if I turn that over, that's definitely not a right angle, and so it is, in fact, neither. Okay, so let's move on to our assignment. Take care of this.